Hi students, how are you? I hope all are doing well. All are preparing hard for your examination. So today I am back with another video and we are following our PYQ series, and today we will be discussing the topic Ionic equilibrium. So we will be discussing the questions which came in 2024 JEE mains from the chapter Ionic equilibrium. So we will move to the question. So the first question, here we have to find out the pH of ammonium acetate. Okay, we have to find out the pH of ammonium acetate, and we are having one weak acid and one weak base. So we know that CH3COOH plus NH4OH will be giving you this particular CH3COO NH4, right, ammonium acetate. So here we have to find out the pH of this ammonium acetate. For finding out the value of pH, we are having the formula pH is equal to 7 plus 1 by 2 of pKa minus pKb. So I hope you remember this particular formula. So if you know pKa and pKb value, we can find out the pH value. So here we are having Ka value. So we know that pKa is equal to minus log of Ka, right? And pKb is the same, minus log of Kb, right? So we can write minus log of 1.8 into 10 raised to minus 5. And here also we have minus log of 1.8 into 10 raised to minus 5. So here the value will be 4.74. So as we are having the same value for pK and pKb, we can write it as 4.74. So we can substitute this particular value that we have got in this equation. So we will be getting pH is equal to 7 plus half into 4.74 minus 4.74. So you can see that it will become 0. So the entire portion will be cancelled and we will be getting the answer as 7. So here our answer is 7. So what is the pH of ammonium acetate? It is 7. So we got the answer as 7. Now the next question. In this question, we have to find out the solubility of calcium phosphate, and they have given certain options. From that options, we have to say which is the correct solubility of calcium phosphate. So for that, first of all, we will be seeing how this calcium phosphate will be dissociating. So what is that? Ca3PO4 twice. Now it will be dissociating as Ca2 plus 3Ca2 plus 2PO4 3 plus, right? Now I can write KSP. What will be KSP? KSP is equal to 3S square into the whole raised to 2 into 2S the whole raised to 3. Now I can write 3S square will be what? It will be, so it is 3s cube. As we are having 3, it should be 3s cube. So it will be what? 27s cube into 4s square. So here it will be 2, 4s square. So we will be getting 108s raised to 5. So KSP is what? 108s raised to 5. So why we have taken this particular 3? You know the stoichiometric coefficient is 3. That's why we have to raise to 3. Here the stoichiometric coefficient is 2. That's why we have to raise to 2. Right. Now we are having an equation for S. What is that? 10 into W by M. I hope you remember this particular equation. Now I am substituting the value of S. KSP is equal to what? 108 into 10 into W by M the whole raised to 5. So here what will be happening? We can write 1.08. We can write 108 as 1.08. Then I can write 10 raised to 2. 1.08 into 10 raised to 2 into 10 raised to 5 into W by M the whole raised to 5. So now we can see that 1.08 is almost equal to 1. So I can take it as 1, then it will be 10 raised to 2 into 10 raised to 5. It will be 10 raised to 7 into W by M, the whole raised to 5. So the KSP value is what? 10 raised to 7 into W by M raised to 5. So what is the answer? B is our answer. 10 raised to 7 into W by M raised to 5. I hope you have understood the solution. Now we will move to the third question. Here we have to find out which is the strongest Bronsted base. We have to find out which is the strongest Bronsted base. So first of all, we will go through the theory. What is a Bronsted base? The H plus ion acceptor, the proton acceptor is known as Bronsted base. And what is a Bronsted acid? H plus ion donor is known as Bronsted acid. So we have to find which is the strongest Bronsted base, that means which can accept the proton. We have to see. So in this case, nitrogen will be having a lone pair of electron, but you can see that it will be used in the ring. It will be used in the ring and it will be delocalized. So it will not be acting as, it cannot be acting as a strong Bronsted base in this case. Now here also we have a lone pair of electron. Now it will be used for extended conjugation. So we cannot say that it will be the strongest Bronsted base. This particular lone pair of electron will be used in the ring again for aromaticity, right? Now we are having the fourth option. Here you have a lone pair of electron. Now this will be showing the plus I effect, and because of that reason, what will be happening? The electron density of the molecule will be increasing. Because of the increase in electron density, now it can accept a proton, H plus ion. Right, so we have to say that the fourth molecule will be actually acting as the strongest Bronsted base. Right, so I hope you have understood. We will move to the next one. We have two statements. What are they? Aqueous solution of ammonium carbonate is basic. It's right. If you take ammonium carbonate, the aqueous solution, then it will be basic. And what is the second statement? Acidic or basic nature of salt solution of a salt of weak acid and weak base depends on Ka and Kb. It's right. Right. The acidic and basic nature of weak acid and weak base will be depending on Ka and Kb. We know this particular theory. So we can say that both statement 1 and statement 2 are correct. Both these statements are right. Fine. So we will move to the next one. Here you have a problem. The pH at which magnesium hydroxide begins to precipitate to form from a solution containing 0.1 molar of Mg2 plus ions is. So here we have to find out this particular pH when this particular magnesium hydroxide will be precipitating, right? Will be starting to precipitate. So first of all, we will write how this MgOH twice will be dissociating. How it will be dissociating? It will be dissociating as Mg2 plus 2OH minus. Now you can say that Q will be equal to KSP, right? Because at the time this particular precipitate is formed, it will be a saturated solution. Then we can write Q is equal to KSP. So we will be writing the Q here. What is the Q? The product of Mg2 plus and OH minus ion concentration. So we can write KSP is equal to Mg2 plus concentration into concentration of OH minus raised to 2. So what is KSP here? It is given as 1 into 10 raised to minus 11. So we can write it as Mg2 plus. What is the concentration of Mg2 plus? It is given in our question. It is given as 0.1. So we can write 0.1 into OH minus the whole raised to 2 is equal to 1 into 10 raised to minus 11. So we have to write that OH minus the whole raised to 2 is equal to 1 into 10 raised to minus 10. I have taken this value to the right hand side. Now taking the square root, we know that OH minus will be equal to what? 1 into 10 raised to minus 5. Now we can write POH is equal to what? 5. POH will be 5. Now we know the relation pH plus POH is equal to 14. So here, what is POH? We know that POH is 5. So we can write pH is equal to what? 14 minus 5. So the answer will be 9. So pH is equal to 9. So that will be your answer. We will move to the sixth question. So in this question, they have given the pH of benzoic acid and sodium benzoate. They have given the pH of aqueous solution of benzoic acid and sodium benzoate. So what is this benzoic acid? We have C6H5COOH plus sodium benzoate. So we have C6H5COONA. So for this particular solution, the pH is given as 4.5. It is given as 4.5. Now we know that the volume of benzoic acid solution in 300 ml of this buffer solution. So we have to find the volume of benzoic acid. So that is V. We have to find V. Now what is the volume of this particular salt? It will be 300 minus V, because the total volume of the buffer solution is 300 ml. So the salt's volume will be 300 minus V. Now you know that number of moles can be found out by the formula molarity. What is the molarity? It is 1m. So 1 into volume, 1 into V, and here what is that? 1 into 300 minus V. Now we know an equation to solve this particular problem. What is that? We know that pH is equal to pKa plus log concentration of salt by concentration of acid. Now we are having all the values. We will just substitute it. What is pH? It is given as 4.5 equal to, what is pKa? It is given as 4.2 plus log concentration of salt. What is there? It will be 300 minus V. Now we have the acid. What is there? It will be V. So 4.5 minus 4.2. I am just bringing this particular 4.2 to the other side is equal to log 300 minus V by V. Here I will be writing the balance after just clearing this part. We know that 4.5 minus 4.2 is what? It's 0.3. And we can actually approximately say this 0.3 as 0.32. And what is 0.32? So we can write here 4.5 minus 4.2 is 0.3. 0.3 is equal to log 300 minus V by V. So here 0.3 is approximately equal to what? 0.32, which is what? Log 2. So I can write log 2 is equal to log 300 minus V divided by V. So here I can cut this log. So 2 is equal to 300 minus V by V. So it is what? I can write 2V is equal to 300 minus V. Now I can write this particular minus V to the left hand side. So it will become 2V plus V is equal to 300. So here 3V is equal to 300 and V is equal to 300 by 3. So the answer will be what? 100. So my final answer is 100 ml. So the volume of benzoic acid solution in 300 ml of this buffer solution is 100 ml. So in this particular problem, the most important thing is to remember this particular formula. Other things are already given in the question. You can easily substitute the values. I hope you have understood this particular solution. Now we are going to the April attempt questions. So we have completed the January attempt questions. Now we are moving to the April attempt questions. So in this video itself, we are covering both January and April because we are having only less number of questions from this ionic equilibrium. Because of that reason, we are covering both the shifts, right? Now, here we are having two statements. On passing HCl through a saturated solution of BaCl2 at room temperature, white turbidity appears. So what is happening? BaCl2. It will be dissociating into what? Ba2 plus and 2Cl minus. And in the second case, when HCl gas is passed through a saturated solution of NaCl we have, it will be dissociating into Na plus and Cl minus. Now we are adding HCl. So you can see that we are having Cl and Cl is present in both these compounds. Because of that reason, what will be happening? The Cl minus concentration will be increasing, and now the reaction will be happening in the backward direction, right? It will be happening in the backward direction. So what will be happening? The amount of Ba and Na will be increasing, and because of that reason, what will be happening? Here turbidity appears and here precipitate will be formed. That means precipitate will be formed because of the backward reaction. So what is the reason? Because the concentration of Cl minus has increased as we have added HCl. So it is actually because of common ion effect. You know, according to Le Chatelier's principle, now the product side has more concentration. So what will be happening? The reaction will be shifting to backward direction. So I have to say that both statement 1 and statement 2 are correct. Both the statements are correct. Right. Now we will move to the next question. A buffer solution is the mixture of a salt and acid or a base mixed in any particular quantities. This statement is wrong because we know that buffer solution means it is actually the mixture of a weak acid or base plus its respective conjugate, right? So this particular first statement is contradicting this particular theory. So it is a wrong statement. Blood is naturally occurring buffer solution whose pH is maintained by carbonic acid and HCO3 minus ion concentration, right? It is true. This particular pH is maintained by carbonic acid and HCO3 minus. It is right. So I can write that, I can say that statement 1 is false, but statement 2 is true. So third option will be my answer. Now moving to the next question, and this will be our last question in this particular session. For a sparingly soluble salt Ab2, so here we are having a salt Ab2. Now it will be dissociating into what? A2 plus and 2B minus. The equilibrium concentration of A2 plus ions and B minus ions are, so they are giving this particular concentration. So we know that KSB is equal to what? Solubility product. We know that concentration of A2 plus into concentration of B minus raised to 2, right? Stoichiometric coefficient is there, right? So we have to raise it with 2. Now we have to write this particular concentration. What is that? 1.2 into 10 raised to minus 4. And here we have 0.24 into 10 raised to minus 3. Right. So here, what will be the answer here? 1.2 into 0.24 and it is whole raised to 2. So 0.24 into 10 raised to minus 3, the whole raised to 2 can be written as 0.576. Right, so 10 raised to minus 4 and 10 raised to minus 6, it will become what? 10 raised to minus 10. Right, so at last you will be getting an answer of 6.19 into 10 raised to minus 12 m. Okay, so this will be your answer. So what we have done, we have taken the formula of KSP and we have applied to this particular salt, and we have seen its dissociation. At last we have arrived at the answer. So I hope you have understood the solution of this particular questions, and this came in the JEE Mains 2024, and it was kind of complex questions, so you need practice of these questions, and you should not leave it by not practicing it. If you are practicing it multiple times, definitely these questions will be easy for you, and you keep on practicing, try to score good marks in the upcoming examination, and we will be seeing in another video. Thank you for watching. Thank you.